participants. So we can wait for 2 to 3 minutes more. Otherwise, then I'll start, and then I'll start this session after 2 to 3 minutes. Okay. So if you want to, if you have any query, anything you want to discuss, you can. Otherwise, we'll wait for 2-3 minutes more, and then I'll start my session.
Ma'am, t-test is a parametric test. And in parametric tests, while taking the samples, we need to have a sampling frame. But every time we cannot get the sampling frame. So in that case, if asked, then how can we justify that?
Better, like in case sample size, basically is like you have 3 ways of like when you are writing a thesis or a research paper, you can on 3 bases you can justify your sample size always. Like on the basis of your variables, number of variables that you have multiplied by 4. That is one way of justifying it, because number of studies say ki number of, if you have variables in your questionnaire, on that basis also you can decide your sample size. So one way is the second is your LR, literature review also. So you can refer to literature review, and you can always see like such kind of studies, like the kind of study that you are doing in such type of studies, how what was the sample size. And third is there is one formula that I think you people know, on the basis of confidence interval and all, you can always calculate your sample size. So that is how you can calculate your sample size. Sampling frame में what exactly you are talking about?
मैम कि फिर उसमें हम t-test
नहीं, किस केस में you are not getting sampling frame, that is what I wanted to know.
मतलब if we are generally collecting data from questionnaire, so how we do not have a proper list from where the the responses are coming.
You need to get that list, because it's very difficult to justify your study then in that case. So somehow you need to justify it. So like for example, if I am doing a study on like slums of Delhi, so I need to get first the data of slums. How many slums are there? How many people are living in that slum? Then only maybe I may collect a small number also, but then I will give justification why I am not collected. But I need to have the total number, how many people are there who are there in slums. So that is important, because otherwise it will be very difficult for you to like justify your study. Okay. So you need to give proper justification. Whenever you are doing a research, you need to give a proper justification for everything. Starting from your sampling to your maybe sampling technique, जैसे judgmental sampling या convenience बहुत लोग कर लेते हैं बड़े easily, but convenience is not something which is like considered good. तो बाद में फिर तुमको problem होगी if you are using a convenience sampling. So you need to give a proper justification for each and everything that you are doing in your research. Otherwise, your research may not have that relevance, that importance, or you may not be able to publish your paper in that case. Okay.
Thank you.
So, yeah, welcome. So I think I should start. People may join in between. So the thing that I'm going to discuss with you today is about hypothesis testing and the test that you can apply. So starting with hypothesis. So I'm sharing, first thing is that I'll share with you is some of the things related to your hypothesis and your scales and the tests that you can apply in each case. And then I'll share with you the SPSS, the data that you already have and the SPS software that you have, so that we can start applying the test also. So first thing is your hypothesis. So what do you mean by hypothesis? Hypothesis, what is the meaning of hypothesis?
Something that we...
May I?
Yeah, please.
Okay. Ma'am, it is an pre-assumption which is to be tested that whether it is true or not.
Okay, yes. So it's an assumption that need to be tested whether it is true or not. So hypothesis, if you talk about hypothesis, you must have done this before. I believe in your papers also, you start with null hypothesis and then you also have an alternate hypothesis, and then you try to either reject or fail to reject your null hypothesis. Okay, so starting from hypothesis, because something that I'm going to discuss with you is related to hypothesis only. So hypothesis is an unproven proposition or a possible solution to a problem or a guess. In a layman's language, an unproven proposition or a possible solution to a problem or a guess is hypothesis. Okay, so and if you talk about like in terms of statistics, you have two types of hypothesis, null and alternate. So there are two types of statistical inference, estimation and hypothesis testing. Hypothesis testing, you have a hypothesis, and hypothesis is a claim or assumption about one or more population parameters. So hypothesis is always framed in context of population, not in context of sample. Okay, so like if I am saying ki population of Delhi is more people are coming from maybe outside Delhi, then like the people who are staying in Delhi, the population which is there, the most it is more of a metropolitan city, so more people have migrated to Delhi, and the people who are in Delhi right now, they are not true Delhites, but most of the population is a migrated population, or people are coming from different states to stay here. So that is a hypothesis about the total population of Delhi. But when I'll be collecting a data, so I might not collect data from all the people who are there in Delhi, because I need to choose a sample. But when I'll be designing a hypothesis, I'll be designing a hypothesis in terms of a population, not in terms of sample. So hypothesis is always about population. It is always about a population parameter, not about a sample statistics. Sample evidence is used to assess the probability that the claim about the population parameter is true. So you have this assumption that the people who are living in Delhi, most of them have migrated from other states and they are now settled in Delhi. They are not from Delhi itself. So that is my hypothesis. But when I'll be collecting data, I might divide Delhi in 4 zones, maybe south, east, west, and north, and then I'll collect data from each zone. And maybe I'll use judgmental sampling or some other snowball sampling or whatever sampling technique I'll use in my particular study. So I'll use that study, and then whatever result that I get, I'll not say this hypothesis is true for this particular sample. I'll say this hypothesis is true for a population of Delhi. So you collect evidence from sample, but you apply to population. Now, hypothesis starts from null hypothesis. What is null hypothesis? We begin with the assumption that null is true. And any difference between the sample statistics and the true population parameter is due to chance and not a real systemic difference. Okay, so similar to the notion of innocent until proven guilty. So null is innocent. Null hypothesis is innocent until proven guilty, like a criminal. So when a criminal is there in court, so we know that that particular person is a criminal, but he will be treated as innocent until he is proven guilty, until there is an evidence to suggest that this particular person has done some crime. Okay, so similar is the case with hypothesis. We want to reject a null hypothesis. Null hypothesis is a criminal, but that null hypothesis is innocent until it is like the evidence, like my study, my data says this particular hypothesis is not true. So null hypothesis is similar to that criminal who is innocent until he is proven guilty by evidence. For example, somebody has done some crime, some road accident or something like that, and there is an evidence, but until and unless it is proven in court, that particular person will not be considered as criminal. So similar is the case with null hypothesis. So we start with null hypothesis. We want to reject null hypothesis, but that null hypothesis will be true until we prove that it is not true. So that is innocence is our null hypothesis. So innocence, that the criminal, like the same example that I'm giving you here, that innocence is a null hypothesis. And null hypothesis mostly, when you are framing a null hypothesis, it talks about status quo. Status quo means like if I say there is no difference, there is no relationship, there is no linkage between the two things. So that is about null hypothesis. For example, I know that know that there is relation in income and expenditure. है ना? But if my null hypothesis will be there is no relationship between income and expenditure. Or if I know that if there will be rise in price of commodities, there will be like demand will go down. But my null hypothesis will say there is no relationship between price and demand of commodities or goods. So it refers to status quo. So always when you are designing a null hypothesis, you'll always write there is no difference, there is no significant relationship between the two things, there is no linkage between the two things. So that is a null hypothesis. It always contains signs like equals to, not equals to, or lesser than or more than, and it may or may not be rejected. So null hypothesis, we want to reject null hypothesis by giving lot of evidence, but it may not be rejected. Why? Because we know that key something, when we are doing a research, we know that key there is a relationship between two things, or there is a linkage between two things, or there is a connection between two things, but we want to prove it with the help of data, with the help of our study. So but if we fail to reject that particular thing, then we'll say that we fail to reject our null hypothesis. Then is your next is alternate hypothesis. It is just opposite of null hypothesis. It challenges the status quo. So the status quo is that there is no relationship, no association between two variables like price and demand, or income and expenditure. For example, if I am saying, or you can say that academic qualification and your like chances of selecting an interview. So all these things, if like is your there is in your null hypothesis, so alternate will be there is a relationship, there is a linkage between the two variables. It challenges the status quo and never contains equals to, or this sign may or may not be proven, and is generally the hypothesis that the researcher is trying to prove. So alternate hypothesis is a hypothesis that researcher is trying to prove. Evidence is always examined with respect to alternate hypothesis, never with respect to null hypothesis, because we want to prove our alternate hypothesis. We never accept our null hypothesis. We either reject or not reject it. So whenever we are writing in our paper, this null hypothesis either is rejected or we fail to reject our null hypothesis. Some examples of now talking about some of the scales that we have already studied before in some of the previous sessions. So you have studied about nominal scale, ordinal scale, interval, and ratio scales. So what all tests you can apply in these scales? So nominal is a data where I think you know that because you have sessions on that. Nominal is a data where the like male, female, when you are giving code 1 to male and 2 to female. So 1 or 2 signifies nothing, it's just a code which is for male and female. So that is a nominal data. Ordinal is a ranking data where 1, 2, 3, 4 means that there is an order in a particular thing. For example, if I say ki rank something in order of your preference, for example, some soft drinks, if I am saying, so Coca-Cola, Pepsi, and Maaza, Limca. So you can rank them in order of your preference. So that will be ordinal scale. Interval scale mein generally in social sciences we have this Likert scale is considered to be an interval scale where you have 5 options: strongly agree, agree, neutral, disagree, and strongly disagree. And then ratio scales is a scale where you have actual value, true value. For example, if I am taking the information about your income. So income, exact income if you are putting. For example, if I have 50,000 per month. So if I am writing 50,000, so that is my income. Somebody has 50,500, so he'll be writing 50,500. So that will be a ratio scale. But that ratio scale can also be converted in, like this income number of times is converted into ordinal also, where you write down whether your income is less than 20,000, in between 20,000 to 40,000, in between 40 to 80,000, and more than 80,000. For example, if this kind of scale is there, so that is not a ratio scale, that is an ordinal scale, because again you are giving it a ranking 1, 2, 3, 4. So ratio has exact figure, like temperature. Exact temperature will be a ratio.
Ma'am, can I ask one thing? Sorry. Yes. Ma'am, that scale will not be interval.
Which one?
Income one for like up to 20, 20 to 40, 40 to 50, 40 to 60, 60 to 80.
I do have same question. मैम अभी ऑफलाइन रहें क्या? नहीं जी, आपने पूछा वो?
हाँ
आपने पूछा ऑर्डिनल स्केल और इंटरवल का कि जो एज लेते हैं हम और इनकम देते हैं?
Hello?
हेलो
Okay. मेरा connection loss हो गया था बेटा. So what I was telling you that if the difference between the two option is exactly same, then you can have that scale is an interval scale. In ordinal scale, there is a ranking, but you don't know the difference between the two. So if you are saying ki less than 20,000 and 22, 80,000 and 82, 1,50,000, above 50,000. So you don't know na, the exact difference, then it will be a ranking scale. But if you put the difference bilkul same, then it will be an interval scale. Okay.
ठीक है
So these are some of the tests that you can apply. Like in case of nominal data, you have chi-square test, McNamara test, and Cochrane Q test. Ordinal may you have these are all non-parametric tests. Conglomerate Simron sample one sample test, Mann-Whitney U test, Wilcoxon test, Kruskal-Wallis ANOVA, Friedman ANOVA by rank. So these are ordinals. This is ordinal scale, and here you can apply all non-parametric tests. In case of interval and ratio scales, you can apply all parametric tests like t-test. This is t-test
Excuse
of
me, ma'am.
sample. Yes.
Your slide is not visible.
Slide
Yes.
Okay. Sorry. Is it visible now?
Yes, ma'am.
ma'am,
Okay.
yes.
Yes, ma'am.
So nominal, if you have a nominal scale, you can apply these tests depending on whether it's a one group, where there is two independent groups, two dependent groups, more than two independent groups, and more than two dependent groups. One group is when you have collected data from just one group, two independent groups like male and female, two independent groups, they are non-linked. Two dependent groups are where, and two independent groups may like then you have like two dependent groups where you can say ki I am doing some tests, for example, in this particular workshop only, I want to know ki what is your level of understanding of SPSS. I took test before and I took test after. So this before and after analysis, if I am doing, then I have two dependent groups, same people, but they have been asked a particular question and on different time frames. So maybe if this is one example where after having this SPS workshop, whether there is a learning or not, if I'm trying to understand this, then I can apply paired t-test. Okay. If I have collected data on interval or ratio scale, but if I have collected data on ordinal scale, then I'll use this Wilcoxon test and McNamara test if I have collected data on nominal scale. And if there are more than two independent groups, male and female, example I have given here, two independent groups. If there are more than two independent groups, for example, male, female, and transgenders. So I will use, in case of nominal chi-square, in case of ordinal Kruskal-Wallis, and in case of interval or ratio ANOVA. And if more than two dependent groups, again, where I am taking this information twice from same people. So in case of nominal, Cochrane Q test, ordinal, Friedman ANOVA by ranks, and in case of interval or ratio, repeated measures ANOVA. So interval and ratio scales, the tests that are here, these are all parametric tests, and in case of nominal and ordinal, these are all the tests which are called as non-parametric tests.
Ma'am, can you please explain more than two dependent once again?
More than two dependent groups.
Ma'am. Yes, ma'am.
Like here, I have given you one example key. For example, I am collecting data from you people, and I collected data before this SPSS workshop and after this SPSS workshop. So just one group, but twice. Here, if there are more than one group, so two dependent groups, maybe there are two groups, two sets of people, and twice I have collected data from them.
So, ma'am, the time frame is also we are taking before and after, and we are considering two different groups, right?
Yes, time frame so will be there before and after,
Yes, ma'am.
and more than two groups.
Okay, thanks,
Okay.
ma'am.
Ma'am, the first two columns, nominal and ordinal, belongs to non-parametric, and the interval ratio belongs to parametric,
Yeah.
right?
Yes, yes.
Okay.
Okay. So this I've already discussed, nominal, ordinal, interval ratio. Here we have some examples in what cases we can have nominal scales, ordinal like nominal brand numbers, store types, gender classification. Ordinal may generally preference ranking, market position. For example, if I'm saying ki, rank these companies in terms of their market position. So first, second, third, you can give, or social class. If you are doing if you are ranking them, then it will be ordinal scale. Interval may like your attitude, opinion, or index numbers. Like you are measuring attitude, like for example, ki, you can mostly in case of Likert scale, there is one statement, and you have been asked by the researcher that you need to tell them whether you agree with the statement or disagree with the statement. So you will be given option like strongly agree, neutral, disagree, and strongly disagree. Ratio may you have exact number like age, income, cost, sales, market share. Descriptive statistics may these all descriptive statistics you can use for these scales. Descriptive statistics we have already done, I think, on SPSS, like percentage and mode in case of nominal scale. Why percentage? Because here you have just male and female, for example. So you can understand with the help of percentage how many male and how many females were there. Similarly, you can also use mode. Mode is how many times a particular thing is repeated. So mode may you will be able to know how many males were there and how many females were there. Ordinal may because you have ranking, so you can rank them, and you can have percentile and median also, because in median what you do, you keep the data in terms of its rank, and then the middlemost value you take. So that is median. Interval may you can have range or mean or standard deviation, and in case of ratio you can have all thing geometric mean or harmonic mean also. Inferential statistics may nominal may, like I told you, chi-square is there. Ordinal may you have all the non-parametric tests. In case of nominal also non-parametric test. In case of interval and ratio you have parametric tests. So basically I'll just give you a brief of parametric and non-parametric, and then we'll start a t-test with SPSS. So parametric and non-parametric test may the basic differences, assumptions may parametric test always assume that the data is normally distributed and there is equal variance. Data is normally distributed means that there is a bell-shaped curve. When you put the data, okay, and you will try to see what curve it is forming, it will always form a bell-shaped curve. And there is equal variance, which means if there are two groups, then the variance in one group and variance in another group will be equal. There should not be much variance in groups. But in case of non-parametric test, no such assumption is there. Data type may parametric test is always suitable for continuous data. Continuous data means interval and ratio. While in case of non-parametric tests, it is suitable for both continuous and categorical data, which means that you can have ordinal, nominal, interval, and ratio. All. Test statistics, it is based on population parameters, but in case of non-parametric test, it is based on ranks or frequencies. So either because you have either ordinal data, so it will put the data in terms of rank, first, second, third, fourth, fifth. And if you have nominal data, then you will have frequencies. So non-parametric test will always use either rank or frequency, while in case of parametric test, it will always take into consideration all the population parameters. Power, generally it is more powerful, but when assumptions are met. So parametric test will be powerful test as compared to non-parametric test, but the assumption should be met. If your assumptions are not met, it is better to apply non-parametric test. So non-parametric test more robust to violation of assumptions. So more in case the assumptions are violated, then non-parametric test is more robust as compared to parametric test. Sample size, especially when distributions are non-normal. While in case of, sample size requires larger sample size, especially when distribution are non-normal. So if you are not getting a bell-shaped curve, then you need to increase your sample size. So it is always said that with the larger sample size, you will generally get a normal bell-shaped curve. So that is the reason that parametric test always require your sample size should be large enough so that you can get a normal shaped curve or bell-shaped curve, and then you can apply parametric test. While in case of non-parametric test, even your sample size is small, then also you can apply. Interpretation of results, it is straightforward interpretation of the result. Whatever values you are getting, you can put in your thesis and you can write the key because significance level is there. It is less than 0.05, so we have accepted a null hypothesis. So in case of parametric test, mostly you look for significance level, which is the value of alpha, and it should be less than 0.05. While in case of non-parametric test, results are based on ranks or frequencies and may require additional interpretation also. So you cannot straightforward see whether it is just the value of alpha and you can decide, but you will see other things also. So this is about parametric and non-parametric test. Now I'll start with your first test, which is, I'll start with parametric test, and I'll do t-test and ANOVA today with the same data set which is given to you by Sadaf ma'am. So first we'll discuss some of the assumptions that should be there when you are applying a t-test or ANOVA. First thing is, in what case you can apply t-test or ANOVA. So t-test and ANOVA. And the other thing that I'm going to discuss with you is correlation and regression. So what is the difference? In what type of hypothesis you can apply t-test or ANOVA, and what type of hypothesis you can apply correlation or regression. So basically, if you want to see the difference in mean, then you will apply for t-test and ANOVA. Okay, and if you want to see the relationship between two variables, then you will apply correlation. And if you want to see the relationship, but at the same time, you can say that impact of independent variable on dependent variable, then you will apply regression. Okay, so that is the basic difference. So first I'll start with t-test and ANOVA. In t-test and ANOVA, we basically look for the mean and we see whether there is a difference in mean or not. So mostly if you are designing a hypothesis and you are applying a t-test or ANOVA, you will write in your hypothesis there is no difference. You will not write there is no relationship or there is no linkage between the two things that you are using in your study. But what you will write, there is no difference if you are using a t-test or ANOVA, because what you are doing right now is you are actually looking for the difference, whether there is a difference between two groups or not, whether there is a difference between more than two groups or not. If it is ANOVA, then it is more than two groups. And if it is t-test, then there may be just one group or two groups. So t-test can be for one group, t-test can be for two groups, but if you have more than two groups, then you will apply ANOVA. So what are the assumptions of t-test and ANOVA? Assumption number one is your dependent variable should be measured at the interval or ratio level. That is, they are continuous. So your dependent variable should be on interval and ratio level. mostly for ANOVA, because in ANOVA you are looking for dependent as well as independent variable. While in case of t-test, if it is just one sample t-test, so definitely उसमें ज़्यादा difference होगा नहीं. But your dependent variable should always be interval or ratio level, or your scale should always be a continuous scale. Assumption number 2 is your independent variable should consist of 2 or more categorical independent groups, like male, female. There are 2 groups, or you are forming a group on the basis of age. So you can say that kids, and then adults, then maybe senior citizens, kind of 3 groups you can have. So you have 2 or 3 independent groups in your independent variables. Then assumption number 3 is you should have independence of observations, which means that there is no relationship between the observations in each group or between the groups themselves. So if I am saying ki I have 2 groups, male and female, so definitely the participants or the members who are there in male, they'll not be in female. So I have independence of observations. Similarly, if I'm talking about in terms of age, so kids and then adults and then senior citizens. So those who are put in kids, they'll not be in adults, and those who are there in adults, they'll not be in senior citizen group. So the observations are independent of each other. Then there should not be any significant outliers. What do you mean by outliers? Basically, if I will with the help of I think just if in terms of because I cannot draw, although I can draw a graph also, but like just for assumption's sake, I can say that if I'll just draw a line, then the line, the data that I have collected from my sample, I should be able to draw a single line. Either it is moving upwards, like sloping upward, or slope down can be there, or a median line can be there, but there should not be significant outliers, which means ki lot of data should not go here and there. It should fall in that particular line. So that is also one of the assumption. It can go up, it can go down, it can be on same plane, but if I am drawing a line of graph, my data should be there in that particular line only. Then assumption number 5 is your dependent variable should be approximately normally distributed for each category of independent variable. Like I told you, there should be a bell-shaped curve. So that should be there. And then assumption number 6 is there needs to be homogeneity of variance. And for that, we apply Levin's test of homogeneity of variance, which means ki data there should not be variance. Okay. So homogeneity of variance like my data, if I'll draw a line, it will be in same, either going upward or downward or in same line, but it should not be like significant outliers will not be there. So that is a basic assumption of t-test or ANOVA. So I'll start with t-test. Now I want all of you to open your SPSS and open that data file also that is shared with you earlier. I think on which you were working also. Like Sadam was, when she was taking class, she has done analysis on this only. So you all have this file with you? Yes?
Yes, ma'am.
Okay. So here you can see variable view and data view. I believe all of you have this file. So variable view, and from where this data has come, questionnaire also. This is a questionnaire. The study was on customer patronage behavior in shopping mall. And you can see that key here. I have this was about, first question was about motivation. What motivates you to shop or visit in malls? So all the statements which are given here are on Likert scale. So like, for example, if I'm saying I find shopping in mall to be an adventurous activity, strongly disagree, neutral, agree, and strongly agree. So these all I can use as interval scale to parametric test, and I can apply if I am using this data. Motivation wala jo data hai, if I am using that, then I can apply this parametric test. Then again here also, very dissatisfied, neutral, satisfied, and very satisfied. about mall attributes of Indian shopping malls. So again, this is also a Likert scale. I can use this data and I can apply a t-test or ANOVA here because interval level data is here. Then this is ordinal scale, rank. Rank in order of your preference. 1 is for most important, 3 is least important. Activities like festival decor and mall event, live shows, shopping carnivals, sales, discount offers. So इनको rank करना है आपको. You need to rank them, and because this is a rank, first, second, third rank, so this cannot be used in case of parametric tests. Then this one can be used because again strongly disagree, neutral agree, and strongly agree. So here you can see you have questions on nominal scale, ordinal scale, interval scale, all types of scales. So we can apply parametric tests as well as non-parametric tests also. Like here, this is a rank. Here it is a Likert scale. Again, Likert scale, and this all is on nominal scale, like gender, male, female, age, less than 16, 16 to 25, 26, 35, then marital status, family size, 1, 2, 3, 4, number of kids, education. So all these personal background can be put in as nominal data, and the scale that you are using is nominal scale. So here you can see that I have questions on all the scales, nominal, ordinal, interval. So I can use both parametric as well as non-parametric tests. Okay, now going back to your yes.
One doubt.
Ma'am, in this questionnaire, household income that was given under the demographic question, so that will also be in nominal or nominal only?
Household income I need to see क्योंकि exact income तो दी नहीं है, तो it is not a ratio scale, है ना? It's not a
The
ratio.
age is given in the bracket, so it should be the ordinal scale.
Let me check. Household income is 20 to 40, then 41 to 60, 61 to 80, 81 to 1. It can be an ordinal scale, household income.
And also the age.
Yes?
Age. Can we consider age as ordinal scale as well?
1 to 20, difference is less than 16, then 16 to 25, 26. Ordinal, you can consider age also as ordinal.
Okay, ma'am.
You can consider it because it is ranked in order. Okay, so if something is ranked in order, you can consider it. But where you are putting it, you need to see how you are using it. Like I'll be showing you how I am using the data now. Because I'll be using this also, your nominal data also, plus your maybe ordinal also and interval also. So how I am using it, and then I need to take care of the assumptions also. The data should be normally distributed, and there should not be significant outliers. So all these things I need to see. I need to perform Levin's test so that homogeneity should be there. I need to see that also. So nominal, ordinal, interval. Ordinal you can put if you are putting it in, if you are arranging your data in order, then you can say that your data is like having order. So that is an ordinal scale. Ordinal is basically you are putting it in order. First, second, third, fourth अगर आ रहा है, rank wise आ रहा है, एक order है, you are following order, then that is an ordinal scale. Okay. So now coming to your SPSS. अब SPSS का आप खोल लेना. Open your SPSS file. Okay, so this you have with you. All of you have this with you.
No, ma'am, I
You have, why? It is
today
not shared with you?
in class.
It's shared last yesterday through email.
But it was shared yesterday email.
Okay, ma'am.
So you can open your email
Okay, ma'am.
and so you can, but when you will download the spaces right now, I think it will take a lot of time. So you can understand also side by side, you can download it also. Okay. because tomorrow again I am going to take session on SPSS itself, so that will help you. So you can download it. Okay, but for time being, you can follow me also how I am doing it. So okay, so this is your questionnaire: nominal, ordinal, interval. All the questions, all types of questions are there in this questionnaire. Now coming back to your SPSS, I believe all of you have this with you. Okay, so here ma'am has already, Sadaf ma'am have told you how you can import the file. You can import it also, and earlier what we used to do, we used to manually feed also, because बहुत पहले the import option was not there, so we used to manually feed it. So label may some places label is not given. If you want, you can put label also here, also like number of kids, education, occupation. Okay, so this data you already have with you: gender, age, marital status, family size, kids number, education, occupation. So nominal and ordinal scales data, and then from here you have interval scale data. Okay, this is I like outrageous people and things. I like lot of varieties in my life. So all these type of statements are on Likert scale. Okay, so this is this kind of data you have. Now we will see what test we can apply. So I'll start with the basic one. So now go to data view. Okay, all of you can open this data view. We'll start with t-test. T-test and t-test, like I told you, it is here. What we are doing here is we are comparing means, and mean mein what we are doing is we want to see whether there is any difference or not. Okay, so here you can see you have many tests: one sample t-test, independent sample t-test, paired sample t-test, and one-way ANOVA. Then apart from that, you have one sample proportion, independent samples proportion, and paired samples sample proportions. So I'll start with this, your one sample t-test. Okay, not only because we are not only interested in means, we at least want one. We have one sample, and we, for example, and one sample t-test also is required in very few cases, because we are not comparing it with any other group. What we, for example, in this particular study only, if I want to know, there is one question, like here if you'll click here, you have this kids number, or you have this family size. Okay, so here you can see family size may you have 1-member family, 2-member family, 3-member family, and this may be a 4-member families. Yeah, more than 3 hoga, so I can write 4 members. Okay, so for example, I want to know, I want most of the families should at least have 2 members. Okay, so I'll take a mean. So that is a one sample t-test, and what I want to know whether my mean is coming at 2 or not. It should be near 2. If that is my requirement of my study, this family size should be at least 2. Okay, so I can see here there are 4 categories: 1-member, 2 members, 3 members, 4 members. But if I want at least family should have 2 members, so I can apply one sample t-test. Or for example, here you have kids number, so you can see no kids, 1 kid, 2 kid, more than 2 kids. So I want in my study, I should have a family with at least 2 kids. So my average or my mean should come near to 2. Okay, so I'll apply a test here. So one sample t-test what I am doing, I am taking just one sample, and I am looking at the mean, and I am seeing whether my assumption, which is either, for example, if I am taking an assumption I want family with at least 2 members, or if I want a family with at least 2 kids, then I'll use this one sample t-test. Okay, for example, this is a kid's number. Okay, it is already then kid's number, and my assumption is the the family should have at least 2 kids, then I'll use this data for my study. Okay, so here you can see this is mean. It is 1.7367 with a standard deviation of 0.92219. So I can say, and total number was 869. So 1.7376 is near to 2, and my significance level is also near like it is less than 0.005. So I can accept this, and I can say ki yes, most of the family have at least 2 kids. Okay, so this value I'll see, and I'll also see the significant level, and I'll decide ki yes, like my sample has this was the mean in terms of kids number, and it is near 2. So most of the family have 2 kids. So this you can like if you are doing a study and that is your prerequisite, something like this is your prerequisite, and you want to know this, so you can apply this one sample t-test, and you can see a significance level and this number mean plus standard deviation, and on that basis you can say ki whether I'm able to prove this or not. So this is about your and this Cohen's-d and Hedges correction. This is just that tells you ki what is the effect size. So but this value, this is the most important value, mean and standard deviation. Okay, so this is about one sample t-test.
So, ma'am, what should be the mean and standard deviation to consider it?
Yes.
What should be the mean and standard deviation to consider whether it is true or not?
You will see the significance level. It should be less than 0.05. First thing. Second is my mean should be near 2. That was my assumption, and I can see from there that it is 1.733 something, which is near 2, because 869 were the total family members. जिसमें mean जो आ रहा है, average जो number of kids आ रहा है, that is coming to be 1.7339 with standard deviation of 0.9 something. So which is standard deviation is something like अगर layman's language में समझोगे कि variation of data around mean is standard deviation. जो standardly वो data जो होता है, that is standard deviation. So basically your mean is near 2, है ना, 1.7 something is near 2, क्योंकि sample size was also 800 something. So for considering that sample size, 1.7 is something you can consider it to be 2, because large sample size that you have taken. So this is how you can interpret your result. You will see the significance level, and then you will also see the value which was near to 1.7 something was 1.8 with standard deviation of the that will make it like आपका 2 के around ही आ रहा है. So you will accept this कि yes, most of the families that I have took for the study, the number of kids were near 2. Okay.
Okay, ma'am.
Okay. So this was about one sample t-test. Okay. Now moving forward, I'll go very slow. If you have any doubt, you can stop me in between and ask. So one sample t-test is when you are only considering one sample and you want to know the mean, and maybe you have some assumptions ki this should be this only. So you will check whether it is there in my sample or not. Okay, so that is for that you can do this one sample t-test. Now second is your independent samples t-test. Independent sample is like ki male and female are 2 independent samples. Okay, if you are considering more than 2 independent samples, then you will go to ANOVA. But we are not going to ANOVA. We are here only. We are in 2 samples only. So if we have independent samples, then we can apply independent samples t-test. You will click here. For example, if I am taking gender is something that I can take, because gender mein you have just 2 categories. One is for, you can here define group also, like group 1 is 1 and group 2 is 2. Okay, so group 1 mein you have given group 1 was male, you have given it 1, and group 2 was female, you have given it 2. Okay, So you'll, if it is coming there, then it's fine. If it is not, then you can click this and then you will continue. Then, for example, I am interested in knowing amount spent on non-food items. Okay, gender, male and female. Okay, this is one thing. This is a scale data. Okay, because it's a parametric test, so I'll use scale data, and I want to know the amount spent on non-food items. Is there any difference in gender, which means males are spending more on non-food items or females? Okay, so is there any difference in mean on amount spent on food items? This is one question. You can take any other question also. We will do with other questions also. So this is here options में confidence interval, it is already auto set है, so you can keep it like this. Okay, and then okay. So this is the value that you are getting now. Significance level is more than 0.05. So, and this is for Levin's test for equality of variances, which is one of the assumption for parametric test, mainly for t-test and ANOVA ke liye, this is one of the assumption. And because you have not met the assumption, so you cannot use this value. So for this, if you want to, but if you have already collected data and you are not getting significant result here, what you can do is you can always apply a non-parametric test. Okay. So because here, this was my, one of the assumption that equality of variance should be there, and Levin's test is done for that only, कि male and female, में जो like कि the people who were there should not be much difference in the two samples, or you can say the male and female two categories. But Levin's test of equality, acha, sorry, I'm very sorry, you will accept it because it should be more like in case of Levin's test of equality, the significance level should be more than 0.05. My mistake. So it should be more than 0.05. So we need to, we can accept this values. Okay.
Ma'am, how did you define the groups initially? Because I am trying, but I did not get this output that you are showing on your screen.
Analyze. ठीक है. फिर compare means and proportions. Then we are on independent sample t-test.
Yeah.
Okay. Ab gender 1 and 2. You can click on gender. You will define groups. And group 1 is 1 and group 2 is 2. 1 is male and group 2 was female.
ऐसे किया था मैम.
कर लिया?
हाँ ऐसे ही किया था, बट आउटपुट
Then
डिफरेंट
continue.
है. अच्छा, आपने अमाउंट स्पेंट ऑन फूड आइटम्स किया है. मैंने
नॉन फूड आइटम्स. यस.
अच्छा ठीक है, वो मैंने दूसरा टेस्ट वेरिएबल शायद दूसरा ले लिया था.
हाँ.
ठीक, तभी आउटपुट.
हाँ.
ठीक है. ठीक है.
Okay. Is this clear? So there were like here you can see amount spent on food items में male and female में there were 444 males and 425 females. Amount spent on food items में you have mean of 2102 in male and 2212 in female. So almost like you can say that yes, there is no such difference between the two. You can apply this on others also, like if I'm not using amount spent on food items. I can take amount spent on food items,
Food items.
non-food items. Okay. Now I am taking food items. Here you can see that this value is 0.027. Okay. Are you getting?
Yes, ma'am.
You're
Yes,
getting
ma'am.
this value?
Yes, ma'am.
So here you will say ki we will the Levin's test for equality of variance. Here you are getting a significant value. Okay, so there is equality of variance, but we don't want it. So this value should be more than 0.05. It is not there, so we'll not use this test. And what we can do is we can go for non-parametric test. If you're not getting the result, then if your assumption is not met, then what you can do, you can always look for non-parametric test. So it was independent sample. So here we will use this amount spent on food items, gender is already there, and then you will run. Okay, so this is the distribution of amount spent on food item is same across the gender. So you have applied this independent sample Mann-Whitney U-test, and it retains the null hypothesis. It has also not rejected the null hypothesis. It retained the null hypothesis, which means that the distribution of amount spent on food item is same across the gender. There is no difference. Okay, so there is no difference in male and female as far as amount spent on food item is concerned. Is considered. Okay, so this is the value. Here you can see the data, frequency, how many males and how many females were there. You can see that your data is not normally distributed. It is not bell-shaped curve. It is like this. Okay, so that is why we cannot apply a parametric test, because in case of bell-shaped curve, it should be like this only. It should have, it should be like a bell, but it's not like that. So we cannot use a parametric test. And this is about the information about male and female. So you have retained the null hypothesis, which means that you fail to reject the null hypothesis. Is this clear? Yes or no?
Yes, ma'am.
Okay. So you have in case of all parametric tests, you have parallel non-parametric tests also. So if you are not getting a significant result, what you can do is you can apply a non-parametric test. जो उसका parallel में non-parametric test है, you can always apply. Like in case of independent sample t-test, you have this Mann-Whitney U-test. So you can apply Mann-Whitney U-test if you are not able to apply independent sample t-test. If your data is not normally distributed, like here you can see the data is not normally distributed. So you applied independent sample t-test, but you again fail to reject your null hypothesis. Now again going back to your data. Okay, so we have done this one sample t-test and independent sample t-test. Paired sample t-test may we need to have a data where like I told you, for example, if I am interested in knowing what is the difference in your level of understanding of SPSS before and after, like attending this particular workshop. So I have took some test before, and then I'll take some test after your workshop, and then the data that I have, then I'll put it there and then I'll check. So here you need to apply although I am not having right now the data, so I'm not doing this. What you will do, if you will have data pre and post, so here you will put the pre data and here you will put the post data, and then you can apply this test, which is paired sample t-test. Okay, so paired sample t-test may again you will evaluate on the basis of same thing, because you have similar assumptions. The data should be normally distributed, equality of variance, homogeneity of all the 5 assumptions that I have discussed with you. So all the assumptions need to be is applicable here also. The only difference is you have the data which is collected twice, pre and post, for example. So you will use that data, and then you can click on OK. Here I have used the data of 2 different variables. That will not help, although, but what type of results you will get, this kind of result you will get. So it will be pre, it will be post, although that is not a correct thing. So pre and post, you will get pre and post and pre and post. So pre and post may mean if there is a difference in mean. For example, if this data was about your understanding of the species before and after this workshop. So for example, before it is 28 and after it is 7. So it should be other way around. Before it was 7 and after it was 28. So I'll say yes, there is a improvement in the understanding level. So this is how, and then you will see significance level also. This result is not significant, but definitely when you will be applying it on real data, so you may get a significant result. So, but because I'm not going to explain this to you, because this is not the real data, but this is how you can apply paired sample t-test when you have data about like pre and post data for something. For example, or if you have attended some training, if some organization wanted to give training to the employees, so they want to know whether it would be fruitful or not. So what they can do, they can give training to few of the employees, and pre and post they'll test. If they find that yes, there is a significant improvement in the level of understanding of the employees, then they can implement that training to other people also, other employees also. So for all these kind of things, you can apply this paired sample t-test. Then next is I'm still on this means only. So one sample t-test, I explained to you. Independent sample t-test, when you have 2 independent samples. Paired sample t-test, where you have 2 samples, but pre and post data you have. Then next is your multiple ANOVA. So one-way ANOVA is when you have 1 dependent and many independent variables. So I am right now using this one-way ANOVA. So you have clicked on one-way ANOVA. Now this is factor. Factor is key. I should have more than 2 independent groups. So before clicking here, I need to show you what all questions I can take here. So like in case of family size, you can see here you have 1, 2, 3, 4 independent groups. There is one group, one family where they have only 1 member. There are families where they have 2 members. There are families where they have 3 members, and there are families where they have 4 members. So you have collected data of 800 something, 869 something. And in this particular data, you have 4 different types of groups in terms of family members: 1 member, 2 member, 3 member, 4 member. So this is one data that I can use if I want to see whether there is any relationship or any difference with respect to number of members in a family. So I can use this. What else I can, like in terms of kids number, here also I can see what type of families I have. I have families with I have family with 1 kid, I have family with 2 kids, and I have family with more than 2 kids. So here again, I have 4 different groups in this particular sample that I have collected, the data that I have collected. So this particular data may I have families, one group where they have no kids, another group they have 1 kid, another group where they have 2 kids, and then a group where they have more than 2 kids. So this also I can use for ANOVA because there are 4 independent groups. So if you have more than 2 independent groups, 3 or more than 3 independent groups, then I should use ANOVA. I cannot apply t-test in this case. Then education में I have 6 groups. So the data that I've collected here, I have people who have education level till 10th. Then there are people who are undergraduate. There are people who are graduate. There are people who are postgraduate. There are people who are diploma, and there are people with PhD also. So if I want to see in terms of education, is there any difference in mall patronage behavior? Because this particular study was about mall shopping in malls. So is there any difference in terms of education? So I will use this data. So I can see here ki what all different groups are there and what I can use in case of t-test, in case of independent or paired t-test, or in case of ANOVA. So ANOVA, all these are good for ANOVA because here I have 7 independent groups. So now going back, so you can use any of these where you have more than 3 groups and you want to see if there is any difference in terms of groups with respect to shopping. So you can choose any of the group here and you can use any of the like question from here, like amounts spent on food item, amount spent on non-food item, or other scale level data, like at scale ka jo data hai. I like a lot of varieties in my life. So if you want to see ki is this question has to do anything with the education level, with the number of kids in family, with number of family members, so you can always see the relationship. Now going back to our data. So if I am applying ANOVA, again you will go to compare means and proportions, then one-way ANOVA. One-way ANOVA में what I have already taken is family size. Family size में I have seen that कि 4 different subgroups are there. Family with 1 member, family with 2 member, family with 3 member, and family with 4 members. So 4 independent groups are there. And I want to see, is there any difference in this family in terms of a current visit time taken to reach mall? I don't think this is a relevant thing. Family size के साथ I can see कि number of stores. Yes. What?
Nothing, ma'am. Sorry.
Okay. So like if I am interested in knowing ki if the family is big, there is just 1 member, 2 member, 3 member, 4 member. Na? If 4 member family is there or 1 member family is there any difference in amount of spent on food items? So I'll click this. This will be my dependent variable, dependent list, and this is my factor, family size. And I want to see ki if there is a difference in amount spent on food items with respect to family size. So 1 member, 2 member, 3 member, 4 members, is there a difference or all the families are spending almost same amount on food items? So just this is my hypothesis, for example, and I want to see if there is a relationship. So I clicked here and I found it significant. So my null hypothesis is rejected, which means that there is a difference. So before coming to this, let me tell you, because before coming to this, let me tell you what all you need to click before this applying ANOVA. So in case of ANOVA, you have chosen one-way ANOVA. So I have put it here, amount spent on food items, and here on factor family size. Similarly, you can choose any other variable also. At the same time, I also need to tick here. I've already done this. You need to do this. You need to click on this, because we want to apply post hoc Turkey test also. So this post hoc multiple comparison may you need to take this Turkey and then continue. Okay, why I have ticked that, I'll explain it to you. And once you have ticked this post hoc Turkey, then you can click on OK. Okay, so this shows that there is a significant difference in like family in terms of amount spent on food items. Okay, so because this significant value is the first thing that you will see. So if you are getting a significant difference, then you can always say my null hypothesis is rejected. There is a difference, because null hypothesis will say there is no difference, there is no relationship, there is no linkage. So null hypothesis is always like that. So but if I'm rejecting my null hypothesis, then I'm saying yes, there is a difference in amount spent on food items with respect to family size. Okay, so but ANOVA will only tell you that there is a difference, but where is a difference? That will not be given in ANOVA. So for that, we take that post hoc Turkey. Okay, so post hoc Turkey will tell you that there is a difference. Okay, so this is multiple comparison. So this post hoc Turkey will compare whether there is a difference between 1 member and 2 member, 1 member and 3 member, 1 member and 4 member. So here you can see the significant level, and you will find that this is significant, okay, while others are not significant. So you can say that difference is there in 3 members and 4 members. Okay, 3 members and 4 members. The families having 3 and 4 members, there is a difference in amount on spent on food items. Okay, so the difference is not there in 1 and 2 member family. They might be spending the same amount or similar amount, but the major difference is here in 3 and 4 member family, where the amount spent on food item is different. Okay. So this is how you interpret your ANOVA. So ANOVA mein, first thing is you will see the significance level. On that basis, you will reject your null hypothesis. And if you rejected your null hypothesis, you want to see where there was a difference, because there were many groups, and I wanted to see whether the 3 member family is spending more or 4 member, or where is the major difference. So for that, you need to take post hoc Turkey, and in post hoc Turkey, then you will see where the difference lies. Any doubt here?
Ma'am, can you please explain that how do we interpret the difference? I could not understand.
Okay, so what we assume, the hypothesis was there is no difference in amount spent on food items with respect to the number of family members. Okay, 1 member family, 2 member family, 3 member family, and 4 member family. We were having 4 groups. These were the 4 groups. In first family, there is just 1 member. In second family, there are 2 members. In third family, there are 3 members. And fourth family, there are 4 members. 5. So result is significant. So on this basis, I can write I am rejecting my null hypothesis. Null hypothesis was there is no difference in amount spent on food item with respect to number of family members. So I am rejecting my null hypothesis, and I am saying there is a difference in amount spent on food items with respect to the number of family members. But where is the difference? That will not given to you in ANOVA table. So for that, we ticked. When I was telling you what all you need, again second case. Third, this value, okay, this is not less than 0.05, it is 0.08. So difference is also not here. Let me check. It might have taken 1. Because the value is less than 0.05 here. Okay, let me run it again. Because this value is less than 1, so maybe significance level is sometimes 0.05, 1 and 0.001 also. So if it is taking 0.1, then it is less than that. So maybe if assuming that it is the significance level is but it is 95% confidence interval. So I need to check this again how it is giving this, because significance level is not showing in post hoc also. It is not less than 0.05. It is near 0.05 but not less. So difference will be there in 3-member and 4-member family in terms of amount spent on food items. Okay, if we are taking it as 0.1, not 0.05. Okay, Ruchika?
Yes, ma'am.
Okay, but I'll again tell you tomorrow ki, or I'll run it again tomorrow, because significance level is there. So we can say that yes, there is a difference.
Difference.
But where is difference? So difference is not shown here. So I'll run it again tomorrow and I'll see. So maybe it is taking 1. If it is taking 1.1 as your rejection area जो होता है हमारा ना, rejection area, if it is like 0.5, 0.05, 0.001 and 0.13 significance level we take. So alpha की value जो हम लेते हैं, that we can take 3 values. So if we are taking 0.1, then it is below that and we can reject our null hypothesis. But if we are taking 0.05, then this is above that. So we cannot reject our null hypothesis in this case. So I will run it again and I'll see. Okay, because difference is not showing in post hoc Turkey test, but ANOVA is saying that there is a difference. Okay, in terms of amount spent on food items and number of family members. But if it is not showing, for example, if it is not showing and post hoc में भी नहीं आ रहा है आपका, then what you can do is you can always go for non-parametric test. Because if you are not getting results here, if you are not getting result in parametric case, what you can do is you can always run a parallel non-parametric test. तो इसका होता है Kruskal-Wallis, ANOVA का. So I'll run tomorrow maybe few more non-parametric tests like Kruskal-Wallis if you're not getting result in ANOVA, and if you're running post-hoc Turkey and there you are not getting any difference, but like ANOVA is showing that there is a difference but post-hoc is not showing, then you may not use this value in your thesis. So for that you need to run a Kruskal-Wallis test. So I'll see whether the data was normally distributed or not, and Levin's test also we need to see. I have not run it right now. So we'll run that also and we'll see whether there is that value is not significant. And then only we can run this. So remaining part I'll do tomorrow. ANOVA का इसको continue करूँगी मैं. Few of the non-parametric test also, then correlation, regression, and I'll also try, अगर time बचा तो maybe some predictive analysis like decision tree. Because tomorrow I'll not be giving you theory. I'll only be doing this practical things. So I believe he will be able to do this. So I'll try I'll cover all the things in tomorrow's class. Okay.
Okay, ma'am.
Okay. Thank you so much.
Okay,
Any
ma'am.
doubt? Any?
Thank you so much, ma'am.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am.
So chalo, if there'll be doubt, then I'll take it tomorrow. Okay. Thank you.
Thank you for the session, ma'am.
Okay. Bye bye. Take care. Bye.